Hi all, this is Alan with Bothell STEM Coach, and today we are going to do the 2018 AP Calculus BC free response question number 6. So it's a series question. The Maclaurin series for ln at 1 plus x is given by this. On its interval of convergence, the series converges to ln 1 plus x. Let f be the function defined by x times ln 1 plus x over 3. Write the first non-zero terms in general of the Maclaurin series for f. Well, first I'm going to do ln 1 plus x over 3. So what I do here is I just replace x with, because this is 1 plus x, I replace x with x over 3. X over 3 minus x over 3 squared over 2 plus x over 3 squared over 3. And they want the first 4 terms, so I'll just do one more. Minus x over 3 to the 4th over 4. Now, this is just 1/3 x minus, let's see, this is 9. 9 over 2 is 18. So 1/18 x squared plus, this is 9, no, this is cubed, sorry. 27 is 81 x cubed. And then 3 to the 4th is 81. 81 times 4, 324. Minus 1 over 324 x to the 4th. But then I gotta multiply by x here, so my f of x is just equal. So I gotta multiply each of these terms by x, right? So those are my first 4 terms right there. Okay. Determine the interval convergence of the Maclaurin series for f and show the work that leads to your answer. Well, so we have to look at the nth term here. For f, yeah. So it's -1 to the n plus 1. And instead of x to the n, it's x to the n plus 1. Oh, it's x over 3. Sorry, it's x over 3 to the n plus 1. Times x, yeah, times x. So that's -1 to the n plus 1, x to the n plus 1 over 3 to the n plus 1. Why do I say n plus 1? It's not n plus 1, it's just n. It should be n. I'm thinking the next step where I multiply by x, and so I get -1 to the n plus 1, x to the n plus 1 over 3 to the n. Now, this only converges, this is an alternating series. An alternating series only converges if this term, if the limit as n goes to infinity of x to the n plus 1 over 3 to the n, if this equals 0. Okay, that's alternating series. This is how we get convergence. So what values of x? Well, this is really x times x over 3 to the n, right? If you think about, I factor out the x and just go back. So I want to know when this converges. This is a geometric series, and this geometric series converges only when x over 3, when this term is less than 1. So I have this condition. I need absolute value of x over 3 to be less than 1. And so that means absolute value of x needs to be less than 3. So my interval of convergence is it has to be between 3 and -3. Okay. Now let's look at P4 be the 4th degree Taylor polynomial for f about x equals 0. Use the alternating series bound to find the upper bounds of P4 minus f of 2. Okay, this is the alternating series error, not the Taylor series error. I just want to check that. So P4, so the way you look at this error bound, it's less than or equal to the maximum value of, it's actually less than or equal to just the 5th term, the next term in the series. The next term in the series is x to the 5th over 5. But like in this case, we got to map it to f. Oh, so for ln, it would be x to the 5th over 5. So that's really x over 3 to the 5th times x over 5. And that's x to the 6th divided by 3 to the 5th times 5. 81, 343 times 5. I'm going to say 3 to the 5th times 5. Okay. So the alternating series is just the biggest value that this could be. Or it's smaller than the value of the series at 2, so I plug in 2, so it's less than or equal to 2 to the 6th over 3 to the 5th times 5. I'm going to leave it like that because I don't really know how to make that any simpler. I'm not going to do the fractions and the arithmetic that would take to do that one. So we'll see if they accept that answer in their solutions. Did they ask for the general term? Oh, they did ask for the general term. I did find the general term, by the way. I found it for the next part, even though I didn't explicitly answer for part A. The general term is right here. And let's double check that I got that right. X squared over 3, x cubed, yep. Xn plus 1 over n over 3 to the n. That's good. So the radius of convergence is 3. The interval of convergence is negative 3 to 3. Okay. They used a ratio test. I used alternating series tests. It's fine. It doesn't matter as long as you show convergence. Next term in the alternating series. It's the 5th term. So did I do the wrong term? Oh, I did do the wrong term. I misread P4. P4 is not the 4th term, it's the 4th degree term. So they stopped here, so I need to look at this term. So this should have been 2 to the 5th over 3 to the 4th times 4. And so that's where I mixed that up. Yeah. Okay, but everything else is basically right, other than I kind of misread what P4. I did the error for P5 minus 2, not P4. So slight mistake there. So I would have lost the point for not using the 5th degree term. But hope you found that helpful. I'll see you in the next video. Thanks for watching the video, guys. Please leave a comment, like, or subscribe below to catch up more of the content. And see any links below. I offer free homework help on Twitch and Discord. See you guys in the next video.